How does SHA-1 hashing secure Git version control? Imagine trying to keep your code safe and organized while working with a team. That's where Git comes in, helping you track every change. But how does Git make sure your code stays intact and unaltered? That's where SHA-1 hashing plays a key role. SHA-1 stands for Secure Hash Algorithm 1. It creates a unique 160-bit string, called a hash, for every piece of data stored in Git. This includes commits, files, and directories. Think of it like a digital fingerprint that's specific to the exact content. If even one tiny detail changes in a file or commit, the SHA-1 hash will change completely. That makes it easy to spot any accidental or intentional modifications. When you make a commit in Git, it generates a SHA-1 hash based on the content of that commit. This hash then labels the commit, so Git knows exactly what version of the code it is tracking. Every object in the repository, like a file or a snapshot of the project, is identified by its SHA-1 hash. This way, Git can quickly find and reference specific versions without confusion. SHA-1 also helps maintain the integrity of the entire project history. Each commit references the previous one by its hash, creating a secure chain. If someone tries to change an earlier commit, the hashes will no longer match, and Git will flag the inconsistency. This chain of hashes makes it nearly impossible to alter history without detection. Another important point is that SHA-1 checks for accidental corruption. If your data gets corrupted due to disk errors or other issues, the hash mismatch will alert Git that something is wrong. It can then reject the corrupted data, keeping your project safe. While SHA-1 was originally created for cryptography, Git uses it mainly for data integrity. It doesn't rely on SHA-1 for encryption or security against hackers. Instead, it ensures that your code's history remains consistent and unaltered. However, advances in cryptanalysis have shown that SHA-1 can be vulnerable to collision attacks, where two different pieces of data produce the same hash. To address this, Git has started supporting newer algorithms like SHA-256, which are more collision-resistant. But for most day-to-day version control tasks, SHA-1 still does a good job of keeping your data trustworthy. Understanding how SHA-1 works in Git helps you see how your code history stays reliable. Whether you are working on a small project or managing large code bases, this hashing system keeps everything consistent and safe from accidental changes. It's a simple yet powerful way to make sure your version control system is dependable.